Just kidding. No. Okay, just kidding. Okay. Hi. So this is the continuation of the notes from class. This is notes, let's see, what color do we like? 1.3.1. This is for your Flipbook. Okay, you should already have written in your Flipbook this title right here. Okay, the law of sines in the area of triangles, / etc., etc. Do not write in this area. There's stuff that's coming. It's just that I blocked out everything else, one thing at a time. So do not write Flipbook, all of that's just for you to know, okay? Do not write here, okay? I'm going to slowly unveil the contents of the wonderful math. Okay, so we're first, so again, just kind of have a big picture. You should divide your thing in half. On the left side, we're going to do the area of non-right triangles, AC. And on the right side, we're going to do the law of sines over here later. And then we're going to do examples on the bottom half. So over here is your actual notes, and then here's examples, okay? All right. Isn't that cool? All right, I have some guest speakers, or never mind. Okay. All right, so we talked about this in class briefly. Hopefully, I'm not sure if I got as far in every period, but this is the area of non-right triangles, okay? Back in, 7th grade or even before, we learned how to find the area of triangles, right? We learned that the area of a triangle is 1/2 base times height. But that only works for triangles that where the base and the height are perpendicular. So usually it's useful for right triangles. If it was a non-right triangle, we had to find the height that was perpendicular inside, right, to the base. But what if we have a triangle, like an oblique triangle is what we call it, where there's no right angles? We don't know the height. We don't know. No sabemos. We don't know the height. And none of these are perpendicular here, right? So how are we going to find the area? Well, in class we talked about this new formula. It's the area for non-right triangles. It's called the SAS formula because this works if we know the side, we know two sides basically of the triangle, and we know the angle in between. So we know the SA and the S. Okay, in that case we can use this formula. The area of the triangle is 1/2 times the two sides multiplied together. That's like our normal formula. But since this is not a right triangle, we have to multiply by sine of C. Does that make sense? So the area of a triangle is 1/2 AB times sine of C. Obviously, if this was called P and this was Q and this is R, then it would be 1/2 P times Q times sine of R, whatever. It doesn't have to be ABC, but we all know that. Okay. All right. Does that make sense? Well, if your name is Carla, then it doesn't make sense to you until you see a concrete example. So we'll do that next. Okay, so now let's look at an example. So, for example, find the area of this non-right oblique. Another word for non-right is oblique triangle. Now, if you're like, Miss Han, you're moving too fast, take a moment and breathe and realize this is a YouTube video, so you could pause. Copy this down. I suggest you just watch. When I'm done with the video, then copy down. But just for now, watch. Don't try to listen and write at the same time. Okay? I have some nice color coding here, so follow along. So if I have a triangle here, they ask me to find the area, and right away you're thinking, oh yeah, 1/2 base times height, but then you're like, wait, where's the base? Okay, let's say 8 is the base. Well, where's the height? Is 9 the height? No, because the height has to be perpendicular to the base, and we don't know what that height is. So again, if I'm talking too fast, this is a YouTube video, go to the little settings and then press half, and you'll hear me talking half time, and it might be better for you. Okay, so again, we can't use the regular 1/2 base times height formula, but you realize, hey, I have two sides and I have this angle in between. I have SAS, so I can use the SAS non-right triangle area formula for this problem, which is the formula right here. So the area of this triangle is going to be 1/2 the A time, or this is A because the way we name it anyway, 1/2 one of the sides times the other side times the sine of the angle in between them, which is what I have written aquí. 1/2 9 times 8 times sine of 27, which is of course half of 72. Half of 72 is 36, and 36 times, you get this from your calculator. Okay, make sure you're in degree mode. Sine of 27. When you multiply that all together, you get the area of your triangle, which is 16.344 centimeters squared, since we're doing area. Now, a note about if you look in your book on page 48, it tells you a note about rounding. When we do angles, you want to round to the nearest 0.1 degree, and the sides of triangles, we want to round to the nearest 0.001. Okay, that's why you have 3 decimal place accuracy here. If you just put 16.3, that's not quite accurate enough. 16.34, still not quite good enough. If you put 16.344, that is good. But make sure you don't round off until the very end. In between, like if I started rounding off right here and multiplied it by 1/2 70, I'm not going to get as accurate. I'm saving all the numbers until at the very end. Just kidding. I can round it off. Okay? Questions? Well, if you do, I'm not there. So, haha, just kidding. You could pause, you could email me, whatever. Okay? But just think about it. Alright, moving on. Good. So that's an example of using the law of signs. Okay, so what just happened there? Okay, so now on the other side, I want you to write the law of signs. Now this is really, really cool. Some people really like this. I remember Kenyatta and Damien and my 6th grade were going all crazy because it's very useful. To be honest, I never learned this until about last week. I don't think my teachers ever taught me this, but now that I realize this is a very useful law. This law works for any triangle. It does not have to be a right triangle, which is the best part about it. It works for oblique triangles as well as right triangles. Now, what does it work for? So it determines a ratio between all the sides and all the angles. Just a note about notation. Notice that I put all the angles in capital letters and all the sides in lowercase, but the lowercase letter is across from the angle. So capital A is across from lowercase a, capital B is across from lowercase b, capital C is across from lowercase c. Okay? Don't you like this? This is so cool. Okay, so let's see what else. So this law of signs, and if you want to know why it works, we did it in class. It's in problem 194 tells us why this law works, the law of signs. But basically, so I'm not going to talk about why, I'm just going to talk about how. So the sine of this angle divided by the ratio of that angle divided by the side opposite is equal to the ratio of the sine of B divided by the side B is equal to the sine of C divided by little c. That's beautiful. Because basically, if you already know any of these and you're just missing one piece, you can use this ratio to find the other pieces. Now there's 2 proportions here, 3 ratios here, but you use them 2 at a time. For example, we can use these 2. Let's say you already know these angles and you know this side and you just are missing that one side, B. Then you could plug everything in and solve for B. Okay? What if you know angle A and you know side A and side B, but you just don't know angle B? You could plug this all in and solve for big B. Alright? Big B. Alright, what if you can use these 2 and make a proportion out of those 2? Right? Or you can use these guys. Okay? So whatever you want, cualquiera, okay? You can use it. So let's see one example. Carla, it's coming. Just wait. Okay? Here we are. Alright, good. Solve triangle CAT. Now, if you've been following along and doing active reading, you should know when I ask you to solve a triangle, that means find all the missing angles and all the missing sides. Give me all the down low on that triangle. Okay, so here they've already given us, this triangle, they gave us 2 angles and 1 side. That's ASA. Based on that, there's only one triangle with a certain ASA, so that means we should be able to solve this triangle because we know ASA works, right? It determines the triangle. We should be able to find everything else. What's the first thing we could find out? Well, obviously, if you know that 2 of the angles are ready, you could find the 3rd angle because of the triangle angle sum theorem. You know that all the angles of a triangle add up to? Very good, 180. So you could add and subtract from 180. You should be able to know that this other angle is 38 degrees. So I'm going to go ahead and write it in here. I didn't write it in originally, but now that you see I'm doing my work. Okay, so this is 38, right? Alright, now we know that angle is 38. Now we know all the angles. If you've already determined the angles of a triangle, you already know the shape of the triangle. You just have to lock in the size. Well, the 8 here already locks in the size, so we should be able to figure out the other sides. How? ¿Cómo? Using the law of signs. Okay, so let's start with this. So since they told us 8, so we're going to use the sine of 38 divided by 8. That's what I have here. And that should equal, now I could choose any of the other ratios, but since, yeah, it's up to you. So let's start with A. That should equal the sine of 127 divided by A. Okay, so again, let's look at this. I'm using the sine of this angle divided by this side should equal the sine of this angle divided by the opposite side. Okay, once you set this ratio up, now it's really easy because you guys know how to solve proportions, right? You can just cross multiply. So A times sine of 38 equals 8 times sine of 127. Now these, I could put into my calculator and get a decimal right away, but do you think it's better to write like a 10-digit decimal or just to write sine of 127? It's the latter, right? So I'm just going to keep it like that and put it in my calculator into one long step at the end. So look, I'm looking for A. So to isolate A, I just divide sine of 38 on both sides. Once I do that, A is by itself, so A equals 8 times sine of 127 divided by sine of 38. This beast I could put into a calculator literally by typing in 8 times sine of 127, make sure you're in degree mode, divided by sine of 38. Alright? Once you've done that, your calculator should tell you a long thing, but you just round off to the nearest 0.001, so you should get 3 decimal places. So your answer is 10.378. And since we're finding the side, a side should be not centimeters squared, just centimeters, and so that's our A. So we found this side is 10.378. Okay, and now the only thing that's missing is side C, and I didn't do the problem, but you can just use now a different ratio to find side C. Okay, to find side C, now that we know this is 10.378, I'm going to do, let's see, sine of 38 divided by 8, so I'm using this angle here, sine of 38 divided by the side equals sine of 15 divided by this missing side, and then I could do the same thing, cross multiply, isolate, use my calculator to find C. Alright, I hope that was helpful. Make sure this is in your notes. I will be checking and we'll be moving forward, adelante, tomorrow, Monday. So make sure this is in your notes and come prepared with any questions. Alright. Bye.